Hey everyone, in this video, I'm going to discuss about, one of the interesting metric which was used to evaluate a linear regression model versus MAE. What does MAE stands for? MAE in the sense, it's a mean absolute error. It's a mean absolute error. So what do you mean by mean absolute error? So basically, what this mean absolute error will do, it's one of the metric used to evaluate a regression model, which basically helps you in finding average absolute difference between the actual and the predicted value. Okay, so this MAE measures average, not just average distance, it's an average absolute difference. Average absolute difference between actual and predicted values. And the formula is given by MAE equals 1 over n summation absolute difference between actual minus predicted. So we all know that y is basically called as actual and y hat is predicted. Okay, now you might have a question, and n basically represents a number of observations. Okay, yeah, why MAE? Why are we going with MAE value? So, one important thing, since it uses a absolute, it converts all negative errors into a positive errors. Okay, why mean absolute error? So, because of that absolute nature, because of absolute, it converts all negative errors to positive. Okay, so what interpretation usually you get by calculating this mean absolute error? So here, all the errors will be treated equally. Okay, since it's just a normal difference, absolute difference, all the errors will be treated equally. We are not adding any extra penalties to our larger errors, so everything treated equally. And one more interesting thing related to this mean absolute error is lower the MAE value, better the model. Okay, lower the MAE, we would say it's better the model because it's a error, right? We are calculating. So obviously, if error is low, the model will be obviously it will be best, right? For example, if in case you want to know it, let's say for example, like how this MAE is calculated. Let's say you have an actual value and a predicted value. Let's take up a marks. Let's say actual marks is 20, predicted is 22, and then we have 30, 31, and then we have 40, let's say 42, and then 50, 55, I'll say 80, 82. Okay, in order to calculate this MAE, what your model will do, it just finds the error first. That's a loss. Actual minus predicted, y minus y hat. So you'll get a difference. 20 minus 22 minus 2 minus 1 minus 2. So minus 5 and here again minus 2. So once you get the loss, so now you can actually calculate MAE. So we know the formula, right? How many observations are there? So it's a formula is 1 by n. Summation absolute difference between actual minus predicted. So already I found actual minus predicted. So you can just substitute. So your MAE is going to be 1 over, so total 5 observations are there into. So modulo of minus 2 first case plus modulo of minus 1 plus modulo of minus 2 plus modulo of minus 5 plus modulo of minus 2. See, because of this absolute modulo, it converts our negative numbers into a positive, right? So it becomes 2 plus 1 plus 2 plus 5 plus 2. Sum everything and then just try to calculate it. So 5 plus 10, 10 plus 2, it's a 12 by 5. So we can say 5 twos are 10, 0.5 fours are 20, 2.4. Okay, so this is how MAE is calculated, which is one of the important metric used to evaluate a linear regression model. I hope it's clear. This is all related to mean absolute error, which finds the average absolute difference between the actual and the predicted. So lower the MAE value, the better will be the model. Thank you. Happy learning.